In this video, I'm going to talk about the future value compounding interest calculation of a series of equal amounts or equal payments. And a series of equal receipts or disbursements, amounts or payments, is called an annuity. So this is FVA, the future value of an annuity. All right, so we're going to be using a series of equal payments instead of a lump sum as we did for future value. So how much will I have in 3 years if I deposit payments of $1,200 per year every year, earning a 5% rate of return? So let's start out with the interest rate, 5%, and it's important to use the percent sign so that you don't end up with 500% by entering the number 5. Number of periods, in this case it's 3 years, and our payment is going to be $1,200. We're going to be putting $1,200 into our savings every year for 3 years. Present value, we have none because we're not using a lump sum. If we already had $3,000 in there and now we were adding $1,200 a year, that's how we would use the present value, but we're not this time. All right, so now our next challenge before us is to find the correct interest factor. So we're going to look at the future value interest factor of an ordinary annuity. You see that? An ordinary annuity means that you use the money for a month and then you pay the interest. From the perspective of the bank, you deposit your money for a month, and at the end of the month you earn your interest, okay? And that's an ordinary annuity. All right, so 3 years is over here, and 5% is right here, so let's go down and see that our interest factor is going to be 3.1525, and I'm going to enter that now. All right, 3.1525, and remember that money is worth more in the future because you can earn interest on it. And that's why the interest factor is a number greater than 1, because it's worth more in the future. All right, and to calculate, I'm going to cell E8. To calculate using the interest factor method, all you do is multiply the payment times the interest factor. So I'm going to begin with the equals, so Excel knows we're going to do math. 1,200, I'm clicking on that cell, times the interest factor. We'll have $3,783. And recall that we are using cell references so we can play what-if analysis. Okay, I needed $4,000 for my vacation. So what happens if I put $1,500? So I change that input and it immediately cascades and I can see the result. All right, I'm going to hit the undo button to get my 1,200 back. Now let's use Excel. So I'm going to click in cell E9. I'm going to hit the insert function. Here's future value because I've already used it. I'm going to hit OK. The interest rate is 5%. The number of periods is 3 years. Payment is $1,200. We're putting in $1,200 per year. Present value, we can leave that blank or we could put 0 in there. And remember, I mentioned ordinary annuity. If it's an ordinary annuity, you don't need to put anything in there. Okay? That stands for 0. If it wasn't an ordinary annuity, you'd put a 1 in there. But we're only going to deal with ordinary annuities, so you never have to put anything in there. All right, I just want to negate the payment so that it appears positive instead of negative when I hit OK. So there we go. And remember that you can double click and there's this cool rangefinder feature that color codes all the arguments. In other words, all the individual components you put into that function. You can edit that in the cell. You can edit it up here in the formula bar, or you can hit that insert function box and get your dialog box back. And that's it.